I promise I'll get to tsunamis in just a second. But first, I have a couple of quick questions. By show of hands, how many of you enjoy a picnic? Great. And again, by show of hands, how many of you are vegans or vegetarians or have some other dietary restriction? All right, thank you so much. Now, I do apologize, I'm not actually planning a picnic. But if I were, and I only asked that first question, I would pretty quickly run into issues with the amount of food that some of you can eat. That's because when you're planning for a picnic, you need to know not only how many people will be there, but also what type of food they can and will eat. So you ask questions about their diet. Are you vegan, vegetarian, etc.? To bring it back to tsunamis, when you're planning for a tsunami, you need to know not only how large the tsunami will be, but also what aspects of the building and its surroundings will influence the forces acting on the building and the performance of that building under tsunami loading. So we ask questions about the structure. Does it have openings that will allow water to flow through it more easily? Is it rotated relative to the flow to allow water to move past it more easily? Fortunately, we've been able to discover how these different parameters influence loading over the past 20 years, following disasters like the 2004 Sumatra tsunami and the 2011 Tohoku tsunami. My research seeks to continue this trend by investigating topics such as flexibility in structural models. Thus far, all experimental modeling has been done on stiff structural models that don't move very much when the water hits it. By introducing flexibility, we hope that we'll be able to see potential decreases in the forces acting on the structure. Now, when we are planning for a picnic, we want to know how much food we need to buy, so we don't buy too much and go over budget, and we don't buy too little and run out of food halfway through. We hope that by better understanding how parameters such as flexibility in our structure influence the structural performance, we can develop more efficient and resilient structures that make better use of the monetary and carbon costs that go into building. So remember, next time you're planning for a picnic, it might not be rocket science, but it's pretty close to tsunami engineering.